Civil 3D for Landscape Architects. That is the topic, and I am your host, Jared Gorby. A little bit about myself. I was a West Virginia University graduate, class of 2011. Got my Colorado state license in 2021. My career's been focused on landscape architecture, physical planning, and visualization. I've worked in many states, including West Virginia, Pennsylvania, Massachusetts, Colorado, Wyoming, Kansas, California, Nevada, Utah, and the Ute Mountain Ute Reservation. I started my career with AutoCAD and did that for 10 years. In the last 5 years, I've switched to Civil 3D. Some notable projects during my career, I've done a 2,000-acre master plan community up in lovely Cheyenne, Wyoming. I did a wolf sanctuary outside of Fort Collins, Colorado, and I did visualization for a utility scale solar farm in the Four Corners region. So that's a little bit about myself, jumping right into the CAD. What I'm going to do for this is show you how I would design a new park project. And this is a park that I've already scouted out locally. So we'll go ahead and start a new drawing. And I'm just gonna, first things first, save as. I'm gonna go to, I've created this folder here, I've called it Hartman Park. And I'll just save this with some naming convention. And I know some people call their drawings bases, some call them masters. It doesn't really matter which you use as long as you're consistent. So we got our drawing saved. What I first want to do before we do anything here in Civil 3D is we want to grab some GIS layers. So whatever jurisdiction you're searching in, you can search your city or county and then GIS data. So I'm in Jefferson County here, and I've tried going to the city, and I know the city doesn't have it. So when you get to the web pages here, you want to not go to these map services. You want to look for where it says data download. So I'll click this data download again. Down here, I'm going to go to data download to this ArcGIS hub. From here, I can find data, lets me browse. And I know from experience that this county has lots of voting, political layers. We're looking for some more tangible stuff. So I'll just keep scrolling until I find it. There's streets. Those are street center lines, zoning data, parcels. And since I'm not doing a subdivision, this is going to be a park. I'm not going to grab subdivisions. So when you come here, you may see too many records. So to fix this, you just have to zoom into your site. Just have to find my site up here. There it is. And zoom in until you see the blue line show up. Then you can hit download. And I go for shape files. This has coordinate systems baked into the files, and I've got a data folder here which I've set up. So I'm going to just save that there. I didn't get that message on the zoning, so I'll just download that. And sometimes when you download these shape files, they're just empty. So there's just weird errors with things sometimes. So my backup, if I can't get a shapefile to work, I'll go for that KML, which is like a Google Earth format, which is about the next best thing to a shapefile. And that last one was pretty big, 158 megabytes, so it's going to take it a second. You'll notice, though, these are zipped files. So we cannot open these zip files with Civil 3D. To use them first, we have to unzip them. It's as easy as just clicking on it and hit extract all. I'll just extract it right where it is. Extract. Parcel just finished. So now, with our shape files loaded in, back in Civil 3D here, we can go to map import. Use that command. And you'll see we're now able to see if you try to open these from the zips, you get an error message. So we'll go ahead and I'm going to add the streets first because I can find the site easily from the streets. And It's showing no coordinate systems assigned to the current drawing, which is fine. So I'm going to go ahead and import those, and we'll see we get all the streets. From the streets, our site's right here, and let's just go ahead and map import the rest of our layers. Zoning. But see what happened? It brought in these zones as like hatches, because I forgot to check a specific box when we did the map import. So we'll do map import again, and this time when I click on it, I have to click this box, import polygons as closed polylines. See, now we got now we have all the zoning, and they aren't hatched. So, but it was kind of hard for me to discern them. So before we get too far down the road, I'm going to go to our layers and just stylize these a little bit. Streets, and then zoning, we'll do purple. Just so that I can read them there. Now we can see things a little more clearly. Let's do map insert for our map import for our parcels. And make sure that we have that same box checked again this time, because it's going to import a lot more than just did. So this might take it a second, depending on how big your jurisdiction is. Mine's big enough that you see it just abandons trying to update this progress bar. So just be patient, and it'll come back to life eventually. There it goes. And now you can see we have parcels, which I'm going to stylize with green. Just select all the zoning to the front. All right, so that's way more than we need, because our site is just down here, right? Like, so using the erase command, I'm just going to, let's see, well, first, just for a point of reference, I'm going to draw a circle around our site, and pretty much anything that's outside of that circle, I feel like I can erase. Right, I'll save this. So now we have center lines and some zoning, which isn't terribly useful in this situation, and parcels. So another thing that we're going to need to get, though, is an aerial. So if we do the geo command, we can geolocate this with the map. So I'm just going to go back and zoom to our site. And I'm just going to put the pin on this intersection right here. Match that to my Lineworks intersection. It's asking for a coordinate system. Since we loaded in shapefiles, is able to detect that these are in Colorado, so I just need to select the first NAD 83 foot one that I have, then zoom into the street intersection. I'll turn ortho on to make sure I'm going straight up for north. There you can see we're pretty well aligned with our site. I will point out that you want this geo pen to be as close to your site as you can get it, because of lens distortion. The further you get away from your site, the more off this will be. As you can see, it's pretty close on our site. Like, the center lines look like they're in the center of the road. The parcels are logical to the parcels that they're in. But when you get further away, you see it starts to fall apart a little bit. Yeah, you can see here where like these cul-de-sacs aren't lining up. So that's always been the case with every site I've ever used. So don't expect it to get any better. Just try and locate as close as possible as you can. With that, we can also capture our viewport. I like doing this just because it speeds up our the CAD performance a little bit better. Now we can zoom in and out, and it doesn't have to parse that map server a whole bunch. And you can even resize this. So you can do this for a little bit better performance. And over here on the side, you can change this from optimal to very fine. Very fine will just improve the resolution of it, so you can just get a little bit higher quality. You zoom in and see if I turn it to coarse, it's just a little blurrier and very fine. Let's see, let's make a layer for that. Just call it aerial and put that object on the area. I'm going to change the color of that layer too, because it's sharing green with pixels and I don't want that. So it's magenta. All right, so the next step I just saved, you might want to get some topography so we can figure out, what is our site? Is it flat? Is it a hill? And to get topography, we're going to use a site called the National Map Download. And I put in download because there's a National Map Viewer, and that's what this is. If you want to download stuff, you have to use the download version of it. So again, we'll just point to our site here on the service. We're looking for elevation data, right? And that's sourced from LiDAR, but LiDAR elevation data is very large and cumbersome. I'm getting a message that the server is down while I'm trying to record this, but that's okay. I'll just show you what to search for, and hopefully when you're trying to download this, the servers are working. When you get here, you'll see the elevation source data. This is DEM sources, LiDAR data. It's a bit more cumbersome than what we're looking for. What we're looking for is products, and this is a DEM that's going to be derived from the LiDAR data, so it's a little smaller. We'll be able to use it a lot more intuitively than LiDAR data, because the LiDAR data will download as a point cloud. This downloads as a raster, so this is a lot easier to work with and faster. So with our topography downloaded, before we can get it into Civil 3D, we have to do some GIS steps to it, and you can use ArcMap or Arc Desktop, Arc Pro. I'm using QGIS just because it's open source and free, so we don't have to worry about creating a project for this. We're just going to do a couple simple steps here. First is we're going to add a vector, and we're going to add our street layer. And what this is going to do is it's going to set the coordinate system based off of this street layer. And with that, we can now add our raster. So we'll grab our DEM, click add, and you'll notice I rearrange these a little bit here, put the streets on top. It's way more data than what we need. So we need to trim this down to our site, which is right there. So with QGIS, this is pretty easy. With the raster selected, I'll go up to the raster toolbar and do extraction, clip raster by extent. And this allows us to just draw a box. Just draw a box around. Run, ignore the error. And you see we have our now trim site. The next thing we have to do though is reproject it, because the coordinate systems that these streets are on are different than the coordinate system that this DEM is on. So it's easy with just going back up to the raster toolbar and going to warp or reproject if you're using Esri. The source CRS I'm not concerned about, just the target. We want to make sure it's NAD 83 Central Colorado foot, and hit run. Ignore the error that it gave me, and you'll see we now have a projected layer. All right, so the last thing we have to do is convert this raster from meters to feet, because all the rasters are default meters. You can just Google meters to feet conversion. There you can see it's this figure here. So in our raster calculator, to do this, it gives us our layers here. We want to take the most recent one that we created, that was the reprojected layer. And then with the calculator, down here we do multiply by, and then we do paste meters to feet. Lastly, up here we need to save this as a file, and I'm going to call it DEM feet. And it's got a coordinate system already assigned to it. So with all that, we can hit OK. And now we have DEM that has been trimmed, reprojected, and converted from meters to feet. So with that, it's ready to take it into Civil 3D. And now we don't even need to export anything because we just saved that DEM. So we can jump right into Civil 3D now. And using our tool space, on the Prospector tab, you see we have several tabs over here. On the Prospector tab, we're going to right-click Surfaces and do Create Surface. Now, we're not doing Create Surface from DEM. You might think that's what we're doing because we just use DEMs, but oddly enough, it's not. So Create Surface, and then we're going to just name this XTopo and hit OK. And then back here you can see under Surface, we now have XTopo. But there's nothing showing because this is just an area to make a surface. We haven't actually defined it yet. So under definition, we'll expand that. There we see DEM files. We can right-click and click add, then point it towards our DEM feet. And there you go. You can see we now have our DEM showing up. And if it doesn't show up with contours, you probably didn't create this with AutoCAD with the Civil 3D template. But because when we created this on the start, I hit new, it created it from a drawing template. So it has pre-made styles already loaded into it. You can see those contours, 2 and 10 background. So let's take it down to contours 1 and 5 background. We can see we're getting pretty good information here. Everything's lined up. I'm feeling confident about this. So I'm going to go ahead and save it. So now that we've compiled a bunch of data, we need to organize this a little bit better. When you have a design file, usually you don't have all your base drawing info in it as well. So we need to break out all of this line work into base files. And that will help with collaboration if we have to share anything with engineers or surveyors or anyone else that we might have to work with. First, I'm going to make a XREF out of this topo, and we'll do that by using the wblock command. This allows you to write a DWG. So under the objects here, we had the topo was selected, and you'll see I have delete from drawing so that when we save it, I don't have to come back in and then delete it again. So I'm going to name this XTopo. I usually leave the aerial here. It doesn't need to be an XREF, but you can XREF it if you want. The rest of the stuff, I'm just going to turn aerial off because I'm going to leave it here in this drawing. But the rest of the stuff, these center lines and parcels and these few zoning things, I'm just going to save this all as a GIS base. So now we just want to, let's make a XREF layer. All right, so with XREF layer current, we'll load in 2 XREFs. And now I've kind of cleaned this up a bit to where I can, under options, I can do XREF fading, which I really am a big fan of. We can fade the aerial as well. So that's a good start. I think the next step, though, you'll notice when we look at our surface, we can't discern the slope on anything. So we need to start adding labels to this. So we're going to just reopen up this surface XREF here. And to add labels to it, we just have to click on it. Then up here, you'll see the ribbon changes, and we can go to contour single. Now I recognize the shape of my site here, so we click on the contour, you'll see it adds label. to change the style of this, we just have to select one of them, and under properties, we can come over here to the, expand this a little bit, to the surface contour label style, and onto the drop down, we'll do edit. You just click this, it goes to edit. So to get rid of the accuracy, we need to go under text, under contents. If you click next to here, you'll see these three dots appear, and then we can click here. You'll see on the side we have like formula. When we click on the formula, it basically shows us on the left what is in this formula. And we see currently that the precision is set to thousands. So we want whole integers. And before we hit OK, we need to send this over by clicking this arrow. And you see now that I clicked over, it changed the formula. And if it OK, apply, and OK, OK, now our labels are correct. So I'll save that to get some labels in. And I also would like to see the slope direction here. So while we're here, let's go ahead and turn elevations on. And after we turn it on, we're going to go to the analysis tab and go expand elevations. It typically shows it as blues. I like land because I find this is similar to how GIS does a slope analysis by default. So you'll see the red is lower and the green is higher. So this shows us where our low points and high points will be on the site. So we can kind of see there's some dark points here. To create some labels that we can later stylize as high points and low points for the site, let's grab, I just clicked on the surface here and I went up to add label and spot elevation. I can see these dark areas are coming through here, so I bet these are probably the low points. Let's see, put one next to it. Yeah, see, it's even lower. Then the high point's going to be like up here in this corner. Terribly concerned with how exact it is. That'll be my low and my high points when I get to do some site analysis. Just save that. And we go back to our master here and reload it. We can now see the slope with our site and kind of get a feel for it. I might move that spot elevation a little bit over, so I guess it would be more so the high point is going to be this intersection really. So I'll copy that one back in. Now we should get a higher point. Yeah, perfect. Thanks to everyone for tuning in. If you like this video, make sure you check out the next one here that YouTube has handpicked just for you.